Hi, this is Mrs. Villette, and I'm going to use this video to go over some examples of finding remaining trig values using the Pythagorean theorem. So in this problem, we are given one value of a trigonometric function, the secant of theta, and we also know that theta is in quadrant 4. So we know that our angle is right here. That's not the actual angle, but we know that our angle theta is somewhere over here in quadrant 4. Now we can use the fundamental identity to quickly get the value of cosine. So if we know secant, then we also automatically know cosine is root of 2 over 5. From there, we can use the Pythagorean identity with sines and cosines, which says that sine squared of theta plus the cosine squared theta equals 1. We choose this one because secant and cosine only have to do with x values, and using the Pythagorean identity, sine squared plus cosine squared equals 1 allows us to gain information about the y value. So now we just substitute in what we know. We don't know the sine squared, but we do know that the cosine is root of 2 over 5, and the cosine squared just means to square that number on the outside. So sine squared of theta plus 2 over 25 equals 1. Sine squared of theta equals 23 over 25, so I've just subtracted the 2 25ths from 1. And then we know that the sine of theta is the plus or minus square root of 23 over 25. Now the reason I drew this picture was so that I could determine where my actual point was, because when I take this plus and minus square root, I actually have to decide. Based on the fact that I'm in quadrant 4, I'm going to choose the negative square root, and I can simplify just a little bit. I don't know what the square root of 23 is, but I do know that the square root of 25 is 5. So now I have the sine value. Now that I've got sine and cosine, I can basically get everything else. So I can get tangent by doing the ratio of sine and cosine. So now we can say that the tangent of theta is the sine of theta over the cosine of theta. So negative root of 23 over 5 over the square root of 2 over 5. Those 5's can cancel, and then I will rationalize by multiplying by the square root of 2 over the square root of 2. So I get negative square root of 46 all over 2. I can also get the cotangent by doing cosine over sine. So this would just be the opposite ratio, or you could do the reciprocal of the tangent function, which would have been, prior to rationalizing, negative root 2 over 23, and then we rationalize. So we get negative square root of 46 all over 23. So we have sine, cosine, tangent, cotangent, secant. The last one is the cosecant of theta. And the cosecant of theta would have been the reciprocal of the sine, which we have over here. So now we take the reciprocal of the sine, which is negative 5 over root 23. I rationalize negative 5 square root of 23 over 23. And so now I believe I have all 6 trig functions, the original one that I was given, secant, cosine, sine, tangent, cotangent, and cosecant. So there are all 6 of my trig values. Now if you like that way, then you can stick with it. On the next slide, I'm going to show you a different way to do this using triangles. It's still the Pythagorean theorem, it's just not using the trig Pythagorean identities. Okay, so we'll start with the same information. The secant of theta is 5 over the square root of 2. Theta is in quadrant 4. And I'm going to start by writing secant in terms of its ratio, which is r over x. So we can just go ahead and assume that we're on a circle of radius 5 with an x value of square root of 2. So r is 5, x is square root of 2. Now the reason this assumption works is that all of the trig functions are ratios, so as long as I pick something that has the appropriate ratio, it will work. The one thing that we want to watch out for is that the radius always has to be positive. And if we're in quadrant 4, my x would have to be positive as well. But sometimes we might be given something like tangent of theta is 3/4, but theta is in quadrant 3. So in that case, if we actually look at the drawing, we would realize that the y and the x were both negative. And so we would say that the y is -3 and the x is -4. But that's not the situation we're in, so let's just kind of ignore that for now. So we have the r value, we have the x value, we just need to find the y value. So we plug into x squared plus y squared equals r squared. So root of 2 squared plus y squared equals r squared. Oh, we know what the value of r is, so we actually put that in. So 5 squared. So 2 plus y squared equals 25. Y squared is 23. And then y is the plus or minus square root of 23. Based on the fact, again, like we showed in the last working of this problem, our theta is in quadrant 4, we know we need to choose the negative square root. So now we have x, y, and r, and we can just go through and we can write my sine of theta is my y over my r, so negative root of 23 over 5. My cosine of theta is my x over my r, so root of 2 over 5. My cosecant of theta, oh actually let's do tangent first, just so that we're always doing stuff in the same order. My tangent of theta is my y over my x, so negative square root of 23 over square root of 2, which I then rationalize to negative square root of 46 over 2. And then I just do my reciprocal functions, so my cosecant of theta is my r over my y, so 5 over negative square root of 23, or negative 5 root 23 over 23. Secant of theta I already had, but just to see it would be r over x, so 5 over square root of 2, which is 5 root 2 over 2. And then finally my cotangent of theta is my x over my y, so root 2 over negative square root of 23, or negative square root 46 over 23. You may find that this way is a little bit easier for you, and it doesn't require you to memorize all of those different Pythagorean identities. You will eventually need those later in the course though, so we don't want to forget about them. So if you prefer this triangle way, where you assign values to x, y, and r, go ahead and do that for now, but just remember that you do need those Pythagorean identities later.